We can't see it, we can't prove it, but cold, relentless mathematics keeps pointing to a single conclusion. An enormous mass has been sitting in the dark at the edge of our solar system for billions of years. To understand how we suspect it exists, we have to look at how modern astrophysics operates. The sky noticed something pulling Uranus gently and persistently off its predictable orbit. Working independently, mathematicians like Urbain Le Verrier calculated exactly where an invisible body would need to be to cause that disturbance. They pointed their telescopes to that precise spot in the sky and found Neptune. Gravity leaves a mathematical fingerprint. That historical proof shows us that you can read the shadow of something unseen and use equations alone to locate it. Beyond Neptune, stretching out to hundreds of astronomical units, lies the Kuiper Belt, a vast, frozen wilderness of icy objects that forms a massive shell around the known planets. In 2003, astronomers found an object out there named Sedna. As this 3D map shows, Sedna travels on a bizarre, stretched elliptical orbit. It takes roughly 11,000 years to make a single trip around the Sun. Over the next decade, more objects were discovered deep in the Kuiper Belt, drifting on similarly extreme, elongated trajectories. When you map out the most distant of these objects, a distinct pattern emerges. Instead of being randomly scattered, their orbits are clustered, tilted, and pointing in the exact same general direction in space. If no large mass is out there influencing them, physics dictates these paths should be random. The statistical probability of this exact alignment happening by chance is less than 1 in 10,000. That is a clear mathematical signal. Something incredibly massive is herding these icy bodies into a collective grip. In 2016, researchers Mike Brown and Konstantin Batygin published a paper analyzing this orbital clustering. Their conclusion was direct. A massive, undiscovered ninth planet is doing the herding. Their models point to a super-Earth, a class of planet common around other stars, but missing from our own, weighing in at roughly 5 to 10 times the mass of our planet. It sits somewhere between 400 and 800 astronomical units away. At that distance, a single orbit takes up to 20,000 years. The scientific community takes this claim seriously because of who is making it. Mike Brown is the astronomer who discovered Eris, a massive outer solar system object that forced the International Astronomical Union to reclassify Pluto. When researchers with a proven history of mapping the outer solar system publish data pointing to a hidden world, other astronomers immediately start stress testing the math. Several scientists have challenged the foundation of the hypothesis by pointing to observational bias. Telescopes don't survey the entire sky equally. If observatories spend more time staring at specific, limited patches of space, they are naturally going to find more objects in those regions, creating an artificial illusion of clustering. Brown and Batygin have continuously updated their models to correct for this bias, arguing the mathematical signal persists even when accounting for blind spots. The debate remains fiercely active. Amidst this friction, two physicists published a paper in 2019 asking the astronomical community to consider a different explanation. What if the mass herding the Kuiper Belt isn't a planet at all? They calculated that the gravitational signature perfectly matches a primordial black hole. Formed in the first moments of the universe, an object like this would be the size of a grapefruit, emitting absolutely zero light, yet carrying the exact mass of a super-Earth. Whether it is a dark, icy world or an ancient, dense remnant of the early universe, the gravitational evidence suggests an invisible mass is floating quietly through our cosmic backyard. Finding an object this dark and distant breaks the standard methods of astronomy. Traditional sky surveys are built to find things that flare brightly or move quickly across the lens. Planet 9 does neither. To solve this, we rely on the Vera C. Rubin Observatory in Chile, built around a 3 billion pixel digital camera designed for this scale of search. Its primary mission is to systematically photograph the entire southern sky every few nights, continuously for 10 full years. By creating an immense time-lapse, researchers can sift through the data to catch the slow, imperceptible shift of a deeply hidden object drifting against the background stars. This systematic dragnet represents the most rigorous search of the outer solar system ever attempted. we are closer to an answer than at any point since mathematics first predicted Neptune. Current models of planetary formation don't account for a super-Earth forming 800 astronomical units from the Sun. If it is there, it means our early solar system was a chaotic environment that violently ejected a young planet into the cold. Contrast this blind spot with our massive technological achievements in deep space. We have mapped the cosmic microwave background, landed on comets, and sent hardware like Voyager 1 hurtling out of the solar system. Yet, as this scale comparison shows, Voyager 1, the furthest human-made object from Earth, has been traveling for decades and is still flying inside the theoretical orbital boundary of Planet 9. We operate the most powerful observational tools in human history, yet our own gravitational family still contains a massive blank space on the map. Somewhere in the cold silence of the outer solar system, a giant, undiscovered entity is waiting, and we still don't know if it is real.